Alright, ladies and gentlemen, so in this video we are diving on into a hopefully refresher course on long and synthetic division of polynomials. Now, I have a not so thrilled face on the screen at the moment because I'm with you guys. I am probably the first to admit that doing long division of polynomials and synthetic division of polynomials for that matter is somewhat frustrating, and sometimes you ask yourself, well, why in the heck are we even doing this? Why would I ever want to actually divide polynomials together? And I get it. I do. I understand where you're coming from, so I want to make sure that we are well aware of that. However, all right, there is a place for it, and you're going to see as we dive further into our calculus discussions that actually the remainder of some of these division problems that we do ends up being super crucial in some instances there. So we are going to be practicing on how to do it, and I'm going to ask you to hang tight until we actually start to use them in a little bit better application down the road. Alright, so hopefully I'll make this a fun video that we don't have that same thought on long division and synthetic division that it seems like every student has when it comes to this stuff. So the goals are pretty simple, guys. The goals are to divide polynomials using long division and using synthetic division. So we're going to dive right on into an example, guys. And the long division is kind of one of those things where we don't really need a whole bunch of explanation. I mean, it's pretty similar to how we went ahead and did it the exact same way when we were kids, right? When you were in elementary school and learned how to do long division. It's just now dealing with polynomials instead. So just a quick little reminder, every single time that you are using long division, you have to use the zero placeholders when necessary. So if those degrees or those exponents are skipping terms, you got to make sure that you put a zero placeholder in there when that time comes. So for this first particular example, we are diving on into a long division in which it is asking us to go ahead and divide 6x cubed minus 19x squared plus 16x minus 4 by x minus 2. So let's take a look and let's see if we can refresh our minds as how do we do so. So obviously, guys, on that outside we have our x minus 2, and we are going to be dividing that on into 6x cubed minus 19x squared plus 16x and minus 4. Alright, guys, so first and foremost, what are we going to do? How are we going to go about this? We're going to ask ourselves is how many times does x divide into 6x cubed? Okay, well, x divides into 6x cubed 6x squared times. I'm going to put that over the squared term. Alright, so from there, you remember we multiply 6x squared by x, and so that's where we get our 6x cubed from. And then we take 6x squared and also multiply that by negative 2. And then we get a negative 12x squared from that result. Okay. Then you want to subtract these two on out because these will cancel. A negative minus a negative ends up being negative 19 plus 12 for negative 7x squared. So now here's our next term. So once again, you want to ask yourself, how many times does x divide into a negative x or negative 7x squared? Okay, and so we see that goes in negative 7x times. So negative 7 now being multiplied by x gives us a negative 7x squared, and negative 7 minus 2 is a negative 14x. Don't forget, one of the most important parts is to bring that next term down before we subtract them through. So because negative and negative make a positive, those will cancel on out. And then you're asking yourself, 16 minus a negative 14, so it's really 16 plus 14 for a positive 2x. So once again, now you want to ask ourselves, how many times does x now go into 2x? And of course, it goes in a positive 2 times. 2 times x is 2x. We're going to bring that negative 4 on down before we forget. and 2 times negative 2 is a negative 4. So we will subtract here, and as we can see, everything cancels on that, so we do not have a remainder here. All right, so what does this actually tell us? Well, what's, in my opinion, somewhat of a useful way to think about long division is it's really just a factor. What this says is that 6, let me change colors here, if it'll switch for me. What this is saying is that 6x cubed minus 19x squared plus 16x minus 4 actually can be written as x minus 2 times 6x squared minus 7x plus 2. Well, if you notice it also, that 6x squared minus 7x plus 2, it can also be factored on out. And so this long division allows us to understand that x minus 2 times 2x minus 1 times 3x minus 2 is actually the factored form of our polynomial. And now what we can kind of see in this example here, since we did not have a remainder, is that this would be an easy way to go ahead and find the zeros or the solutions of the problem as well too. All right, so quick little reminder about the division algorithm. What is it? All right, it's utilized when long division gives you a non-zero remainder, a non-zero remainder. So I have an example for you. Let's say, for instance, you went ahead and divided x squared plus 3x plus 5, divided that by x plus 1. That's what you see right down in here. And you did so, and what ended up happening is that you got a remainder, and that remainder was 3. And so if you remember correctly, all right, we are allowed to, by the division algorithm, say that the actual end result was 3 over whatever we divided into it. In this case, it was x plus 1. But the division algorithm lets us also understand that the specific polynomial that we were dividing by, all right, x squared plus 3x plus 5, is also equal to x plus 1 times x plus 2 plus 3. All you really do by the division algorithm, if you see now, guys, is that you multiplied by x plus 1 on both sides of the equation. Do we see that? That's all that we really did in that example. And so that's what the division algorithm does allow us to actually do. All right, let's do one more of our long divisions before I let you guys give one a shot on your own. So we're going to say x minus 1 into x cubed minus 1. But notice I put a pause on that. I don't want to dive into it too quick. All right. Reason being is because what ends up happening is that this is our first example in which we don't have consecutive exponent terms. So we cannot forget to add our zeroed terms into our polynomial. All right, so now it's the same concept though. So now we're going to go ahead and say that, hey, divide x into x cubed. Well, we know that goes x squared amount of times. And then multiply by -1, and you get a negative x squared. So multiplying these through, these will cancel. 0 plus 1 ends up giving us a positive x squared. So once again, ask yourself, how many times does x now go into x squared? Well, x goes into x squared x number of times. X times x is x squared. Bring that 0x on down, and then x times -1 is a negative x. So we subtract, and those will cancel. 0 plus 1 gives us an x. And then we want to, once again, ask ourselves, how many times does x go into x? Well, of course, that's going to be 1. 1 times x is x. Bring my -1 on down. And 1 times -1 is a -1. All right? So once again here, guys, we see that we cancel. Negative plus 1 is going to end up being a 0 as well. So we do not have a remainder in this instance. And so we can honestly say that x cubed minus 1 over x minus 1 does in fact equal x squared plus x plus 1. And again, it'll allow us to go ahead and find an easier way to look into our factors or into our solutions if need be. All right, guys, give this one a shot on your own. You need some answer choices in there as well, too, to see if we can get it. And we're on to the next one.